All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course and we're still doing our learning module. Let's have a look at what we went over tonight. Now, last night, if you recall, we were going over different types of classifications, and tonight we're going to build on top of that. So, that then is two different approaches to trying to solve this type of classification problem. One is the nearest neighbor type of approach, where we just take a data point and look at the data points that are nearby to try and estimate what category we think it belongs to. And the other approach is trying to use linear regression, figure out what the weight should be, adjust the weights in order to figure out what line or decision boundary is going to best separate the two categories. It turns out that another popular approach, a very popular approach, if we just have a data set and we want to start trying to do some learning on it, is what we call the support vector machine. And we're not going to dive too deep into the mathematics of the support vector machine, but we'll at least explore it graphically to see what it is that it looks like. And the idea, the motivation behind the support vector machine is that the idea that there are actually a lot of different lines that we can draw, a lot of different decision boundaries that we could draw to separate the two groups. So, for example, we have the X's data points to the left and the O's data points to the right. As you know, our X's represent non-rainy days and our O's represent rainy days. One possible line we could draw is a line like this. As you can see, we have one vertical line that separates our data right down the middle perfectly. So this line will separate our X data points from our O data points, and it does so perfectly. All the X data points are on one side of the line, and all of the O data points are on the other side of the line. But this should probably make us a little bit nervous. If we come up with a model and the model comes up with a line like this. And the reason why is that we worry about how well it's going to generalize to other data points that are not necessarily in the data set that we have access to. For example, there was a data point that fell right here. For example, CE dot on graph on the right side of the line. Well, then, based on that, we might want to guess that it is, in fact, an X data point. But it falls on the right side of the line, where instead we would estimate that it is an O data point instead. Let me go ahead and put the O there. So as you can see, we have an input here of E. It's on the right side with the O's, but it's actually closer to the X's. So based on that information, our model might misclassify it as an O when actually it could be an X. Now that's what we went over tonight. We actually did more graphs like that and more things of that nature, but I'm not going to go into everything because we did do a lot. But yeah, I'm going to keep you posted every step of the way. And for now, you guys stay Gucci. This is the Python Poppy.